For decades, we've searched the stars not just for planets, not just for signals, music, but for anomalies. Those rare moments when something in the cosmos refuses, music, to obey the rules. And now, the James Webb Space Telescope may have found exactly that. What began as a routine observation of music, the third interstellar object ever recorded in our solar system, 3I our Atlas, has turned into something far stranger, far darker, music, and infinitely more important. Because deep in the vast cold void beyond Mars, the Webb detected something it shouldn't have. Not just light, music, but artificial light. A glow that behaves like no comet or asteroid. A signature that follows no known physics of music, reflection, or refraction. And now astronomers and astrophysicists are left with one question that chills them to the core. What is 3I Atlas music really? Stay with us as we dive deep into the data that has just reignited music, the oldest and most terrifying question of all time. Are we alone? 3I Atlas was first spotted as a faint speck, music, on the edge of the solar system, moving with a trajectory no local object could follow. It was clearly interstellar, born beyond the gravitational embrace of our sun, flung across the galaxy by some unknown force, and now, music, drifting silently through our neighborhood. At first, it was treated as a cosmic curiosity, like its predecessors, Oumuamua and Borisov. But even in its earliest images, something felt off. Unlike most interstellar objects, music, 3I Atlas was unusually bright, and not in a way that made sense. Its magnitude didn't correspond to its estimated size or composition. It shimmered with an unnatural consistency. A music, its brightness neither faded as expected nor flared with any sign of outgassing or dust release. Traditional comets tend to brighten in bursts as ice sublimates, but this one, music, remained steady, as if it were powered from within. Telescopes across the globe, music, turned to observe it. And Webb, with its unparalleled ability to peer into the infrared spectrum, music, was brought in to decode the mystery. What it saw changed everything. The James Webb Space Telescope, music, perched 1 million miles from Earth at the Lagrange point, was designed to see the unseen, to cut through the glare of stars and reveal what's hidden in the shadows. Its gaze upon 3I our Atlas was expected to clarify the confusion. Instead, it amplified it. The telescope's music instruments detected a centralized thermal emission that didn't correlate with any natural reflection of sunlight. Typically, a comet shines due to the sun's rays bouncing off music, dust, and ice. But 3I Atlas showed an internal heat signature, something that radiated from music, the core outward. This wasn't scattered light. It was emitted light. The thermal mapping revealed a pattern that followed no known distribution curve of natural objects. Music, pulsed faintly, irregularly, and most disturbingly, it seemed to cycle at intervals. That rhythm repeating ever so subtly, music, suggested not randomness but design. Some scientists at NASA and the European Space Agency proposed exotic explanations. Radioactive decay, subsurface friction, alien isotopes. But as more data came in, those theories, music, collapsed. The only consistent explanation left on the table was the one no one wanted to write down. This object, music, might be powered. As data from Webb, Hubble, and terrestrial observatories piled up, a profile of 3I Atlas began to emerge, and it looked nothing like any known celestial body. Its trajectory was too precise to be chaotic, as if it was choosing its path, subtly adjusting course, music, through gravity wells. Its rotation was unnaturally stable, with a tumbling motion that defied standard inertial drift. And its lack of a cometary tail, even when passing music near solar radiation, suggested a shell or casing, perhaps something protecting it from the heat. Then came the most controversial finding. The albedo, or reflectivity, of its music surface was measured to be nearly perfect in parts, approaching that of polished metal, not rock, not ice, not dust, but metal. The implications, music, hit like a shock wave across the astronomical community. If it was metallic, structured, and emitting energy, then we were no longer observing a natural object. We were observing technology. Suddenly, the term probe was music, whispered in hallways, beacon, craft, even artifact. The idea that this might be an alien spacecraft was no longer music, relegated to conspiracy forums. It was now quietly circulating in institutional emails behind encrypted firewalls. Perhaps the most damning piece of evidence wasn't the thermal emissions, the trajectory, or the strange metallic signature. It was the light. Photometric, music, analysis showed something chilling. The light coming from 3IO Atlas was focused in a narrow spectrum band. In other words, it wasn't a broad natural, music, reflection of sunlight, but a controlled emission of specific wavelengths. This is precisely what we do with lead arrays, music, laser communication systems, and spacecraft signal beacons. Furthermore, this band included frequencies often used in communication and guidance, music, systems on Earth. Not only that, but the intensity of the light seemed to respond ever so slightly to solar radiation, as music, though some onboard system was adjusting it in real time. It flickered not at random, but with a strange intermittent music pulse. Astronomers ran the data through known signal models. What they got was inconclusive, but not meaningless. Some music claimed the pulses resembled binary sequences. Others said it might be a rotating power source. But the conclusion was undeniable. This was not music, a passive object. It was doing something, music, deliberate, and we were watching it live. As the data poured in, a team of astrophysicists from MIT and Harvard ran a deep signal analysis over the electromagnetic emissions coming from music 3IO Atlas.